Alright, so in this video I'm going to finish off the final review for Algebra 2. This one wants me to identify the zeros, their multiplicity, and the effects, whether it bounce or intersects. I think we use bounces or crosses in class. And it gives us this equation. So what I want to do is everything that has an x, I'm going to set it equal to 0. And then I'm going to solve them. So this first one, I divide by 2, I get x equals 0. That doesn't have an exponent, so it just has a multiplicity of 1. And this one is going to cross. Then the next one, I subtract 4, I get x equals -4. This one is a multiplicity of, I go off my exponent, 6. Because it's even, it bounces. The exponent is even. That's what determines if it bounces or crosses. And then on the last one, I add 2. I get 3x equals 2. Divide by 3. I get x equals 2/3. This one has a multiplicity of 3, my exponent. And because my exponent is odd, it crosses. Number 12 says the graph of a polynomial function has zeros of 3, multiplicity 2, and -7, multiplicity 1. Write a function in standard form that could represent this function. So I have x minus 3, multiplicity 2 means my exponent is 2. Then I have x plus 7, my exponent is 1. So I want to go ahead and multiply this out. I'm going to rewrite my x minus 3 without my exponent. So I'm going to multiply two x minus 3's together. Then I want to go ahead and multiply. This gets me x squared minus 3x minus 3x plus 9. And then I'm still multiplying by my x plus 7. I want to combine like terms. That gets me x squared minus 6x plus 9 times x plus 7. Then I want to go ahead and FOIL out. I have x cubed plus 7x squared minus 6x squared minus 42x plus 9x plus 63. Then I want to combine like terms. I have x cubed plus x squared minus 33x plus 63. This next one wants me to factor the polynomial completely, so I'm going to look for what these have in common. They both are even and they both have x, so I'm going to take out a 2x. I'm going to leave that out front, and then that gives me 25x to the 4th minus 9. 25 and 9 are both perfect squares, and 4 is even, so I can use the difference of squares pattern. This is going to give me 5x squared minus 3, and then 5x squared plus 3. And this is my answer, since I can't factor either one of those anymore because neither one is a perfect square. On number 14, I can pull out an x from both of these. I get x times x cubed plus 216. This looks like it might be a perfect square. If I can't remember if 216 is or not, what I can do is I can do math, and then choice 4 is the cube root. I type in 216. It is a perfect square, which gives me 6. So my a is 1, my b is 6, and then I want to use here my sum of cubes formula, which is a cubed plus b cubed. And I have a plus b times a squared minus ab plus b squared. And then I'm just going to plug in for a and b. So I still have my x from out front. My a was x, not 1. I have x plus 6 times x squared minus 6x plus 36. And this is completely factored. Next one, everything can divide out by a 7x. So that goes out front. Then I'm left with 2x squared minus 7x plus 3. I want to factor this. I'm going to use my AC method, so I need to go ahead and identify my A, B, and C values. My A is 2, my B is -7, and my C is 3. So for AC method, I take my A and C values and multiply them together. 2 times 3 is 6. I'm looking for what multiplies to positive 6 and adds to -7. That is -1 and -6. So I'm going to split my middle up. Instead of -7, I'm going to have -6x minus 1x. because that still adds up to -7. And then I'm going to split this into two groups. So I still have my 7x out front. My first group I can take out a 2x. So I have 2x times x minus 3. My second group I can take out a -1. And then I'm left with x minus 3. I want to take my two outside pieces and put those together. So I have 7x times 2x minus 1. And then the repeated part only gets written once because I'm undoing the distributive property here. Okay, on number 16, this one's just by grouping. So my first group I can take out an x squared. And I'm left with x minus 5. On my second group I can take out a -1. And I'm left with x minus 5 again. My outside parts go together. Then this one is a perfect square, or sum of perfect squares, so I can split it up into x plus 1 times x minus 1, and then I have my x minus 5. Okay. These ones want me to solve by factoring. On the first one, they're both, they're both even. Okay, so I'm going to divide them both by 2x. Then I have 4x squared minus 49. It's a difference of squares, so I can split it up. I'm going to have 2x plus 7 times 2x minus 7 equals 0. Then I want to take each of my factors and set them equal to 0 by the zero product property. And then I solve for each x. So on this one, I get x equals 0. Over here, I get 2x equals -7. Divide both sides by 2. I get x equals -7 halves. Over here, I add 7 to both sides. I get 2x equals 7. Divide both sides by 2. I get x equals +7 halves. So all three of those are my answer. On number 18, I want to subtract the 10x over. So I have 80x to the 4th minus 10x equals 0. Then I want to factor out what they have in common. They all have 10x. So that factor goes outside. Then I am left with 8x cubed minus 1. This one is a difference of cubes. So this formula I want to use is going to be a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So my a here is going to be the cube root of 8x cubed, which is 2x, and my b is 1. So the 10x is still up front. I have 2x minus 1. Then I have 2x squared plus 2x times 1 plus 1 squared. Then I just want to simplify my last set of parentheses. 2x squared is 4x squared plus 2x plus 1. So this is my, oops, that's not my final answer. This one wants me to solve. So I want to go ahead and solve this. So I want to go ahead and take each of those pieces and set them equal to 0. So on the first one, I divide by 10. I get x equals 0. On the second one, I'm going to white out this box so I have more room. I'm going to add 1. I have 2x equals 1. And then I'm going to divide both sides by 2. I get x equals 1/2. And then on my last one, I want to go ahead and use the quadratic formula. So my a is 4, my b is 2, my c is 1. My quadratic formula is x equals -b plus or minus the square root b squared minus 4ac over 2 times a. I'm going to plug into that. I have negative 2 plus or minus the square root of 2 squared minus 4 times my a value of 4 times my c value of 1 over 2 times 4. And then that simplifies to negative 2 plus or minus square root of 4 minus 16 over 8, which is negative 2 plus or minus the square root of negative 12 over 8. I'm going to factor tree negative 12, or just 12. That gives me 2 and 6, 2 and 3, so I can pull out a 2, and because it was negative, it's going to have an I out there, so I'm going to have 2i square root of 3 over 8, which simplifies to negative 1 plus or minus the square root of I square root of 3 over 4, because I divided everything by 2. So I only look at my numbers in front of the radicals to divide. Okay, same idea on number 19. I'm going to start off by subtracting 3x squared and subtracting 48 on both sides. So that gets me x squared minus 8x squared minus 48. Oh, x to the 4th is my first one. This factor is just like a normal quadratic. I'm looking for what multiplies to negative 48 and adds to negative 8. That is going to be negative 12 and positive 4. So I'm going to take each of these factors and I'm going to set them equal to 0. On this first one, I add 12. I get x squared equals 12. I want to take my square root, which I know the square root of 12 from earlier is 2 square root of 3. And I get plus and minus because I found 2 different answers. Over here, I subtract 4. I get x squared equals negative 4. I take my square root. Because I'm taking the square root of a negative number, it is going to give me an I. And the square root of 4 is 2. Same thing on number 20. I'm going to subtract the 12x, subtract the 16. So it gets me 3x cubed plus 4x squared minus 12x minus 16. I'm going to factor by grouping. So in my first group, I can take out x squared. I have 3x plus 4 left over. In my second group, I can take out negative 4. Which leaves me with 3x plus 4. Then my outside pieces go together. And my repeated part goes in a group at the end. I'm going to take each of my pieces and set those equal to 0. This one I add. I get x squared equals 4. I take my square root. I get x equals plus or minus 2. Over here I subtract 4. I get 3x equals negative 4. Then I divide both sides by 3. And I get x equals negative 4/3. Okay, the next one wants me to write a polynomial function in standard form with zeros at negative 2, 6, and 3. So I write x plus 2. I write opposite the zeros it gives me. X minus 6 and x minus 3. Then I want to go ahead and just multiply this out. So I'm going to get x squared minus 6x plus 2x minus 12. And I have x minus 3. I want to combine like terms from my first parentheses. So I have x squared minus 4x minus 12 times x minus 3. I'm going to go ahead and multiply out. This gets me x cubed minus 3x squared minus 4x squared plus 12x minus 12x plus 36. Combine like terms. I get x cubed minus 7x squared. My 12x's cancel out. Plus 36. Okay, last one wants me to find the quotient. On this one, I'm going to do long division since I have a number in front of my x. So I'm going to do 3x squared. Nope, not 3x squared. 3x plus 2. And I'm dividing into 9x squared minus 6x minus 8. I'm looking for what I can multiply 3x by to turn it into 9x squared. That is 3x. So that is going to give me 9x squared plus 6x. I want to change my signs on those and subtract. That's going to give me negative 12x minus 8, and I want to write this 3x up above so I know what I got. Then I'm looking for what multiplies to 3x to turn it into negative 12x. That's negative 4. So it gets me negative 12x minus 8. Then I want to change my signs, and I multiply by negative 4. So this one will cancel out nicely, and I don't have a remainder. I just have 3x minus 4 as my final answer. On number 23, I can use synthetic division. So I can take this and set it equal to 0. I add the 2 over, and I get a equals 2. So that means on the outside, I'm going to have a 2. Then I want to write my coefficients down for my dividend. I have 1, 6, negative 25. I bring the 1 down. 2 times 1 is 2. 6 plus 2 is 8. 2 times 8 is 16. Negative 25 plus 16 is negative 9. So I fill back in my x's with 1 degree lower. Oh, in this case it was a's. So I'm going to have a plus 8 minus 9 over what I divided by, which was a minus 2. Same thing on 24. I set this equal to 0. I subtract 7 on both sides. I get w equals negative 7. I have wrong one. So I write the negative 7 up front, and then I write my coefficients here. I have 1, 3, negative 31, negative 26. Bring down the 1, negative 7, which gives me negative 4. Negative 7 times negative 4 is 28. Negative 31 plus 28 is negative 3. Negative 7 times negative 3 is positive 21, which gives me a negative 5. Plug back in my variable 1 degree lower. So instead of cubed, I'm going to have squared. So this is going to be w squared minus 4w minus 3. And then minus 5 over w plus 7. Same thing over here. I'm going to set equal to 0. I add 3. I get y equals 3. So I'm going to have the 3 out here. I want to pay attention to my variables and make sure all of my variable exponents are represented. So I have 4, 3, 2. There's no 1. So I'm going to have a 0, 0 to the y. And I need to represent that 0 in here when I fill in my values for synthetic division or long division if that's how you want to do it. You need to remember to put 0 as a placeholder. Start off by bringing down my 5. 3 times 5 is 15. Negative 23 plus 15 is negative 8. 3 times negative 8 is negative 24. That gets me 0. 0 times 3 is 0. 0 plus 0 is 0. 0 times 3 is 0. Negative 7 plus 0 is negative 7. So filling in my variables, this is going to give me 5y cubed minus 8y squared minus 7 over what I was dividing by, which was y minus 3.